be the tutor as well.
Okay, so Nadia will be your tutor, but meaning that there is going to be additional lectures so that you can see Nadia started recording so that you can feel safe and not scared. And please ask questions in those lectures. And I please want to ask you to ask me as many questions as possible and put them in the chat on the side. And then I just sometimes get carried away and I forget to look. Okay. And I also know it's really awkward to talk in an online class. So, yeah, please ask questions. Please don't be scared. And if you need additional help, please just ask, because I think this is your one opportunity to forever put that monster gremlin to bed and never have to deal with him again. Okay. On that note, hi, my name is Serena. Some of you might have met me in your PDAN classes before, and some of you might meet me for the first time tonight because you're doing the 2-year structure. So I work for Emeris as a research scientist, and I teach stats and Python for data analytics, and some master's courses because I love stats. But I didn't start loving stats. I started being super scared of stats until I had a really, really good teacher who let me understand that stats is easy, it's completely doable, and it is beautiful if you look at what we can actually do with simple calculations. So I'll be taking you for linear regression, logistic regression, and I think neural networks, Nadia. Hey, that's my portions.
Yes, I think I lost the link.
It's okay, we'll find the link. All right.
I will find it again.
And did in the previous class, Nadia, did you guys explain to them why we are following the structure of teaching?
No, we did not get to that part, no.
Okay, so you guys, the reason we have different people teaching you different concepts is it's either a concept someone really loves and will make exciting for you, because not everybody loves everything equally. Stats is a big field. Like I love linear regression, I love logistic regression, and I love neural networks, particularly CNNs. They're my favorite things. And that's why I'm teaching that, because I'm passionate about it and I want to teach you about it. But if I had to teach you GANs, I'd be throwing up in the dustbin. I'd be like, oh God, GANs. Nobody wants to do that. So that's why you guys have a masterclass structure, so that people that use these things frequently and understand them and really enjoy them teaches you different concepts. So you don't have one person trying to be a jack of all trades who makes you then subsequently hate stats. So that's why the masterclass approach is followed. But you will have Daryl, who is the overarching lecturer who will keep you safe throughout the whole semester. And it is Daryl and not Darren, right, Nadia? And he will follow you from day one up until the end. So you don't have an unstructured space with lots of people. Daryl is responsible for you guys from day one up until the last day. He's your point of contact, your central person to get a hold of. And then you just have lectures, but as well as all the lectures are on the WhatsApp group, and we're super duper findable. And if you need us, please find us. Don't be afraid to find us. Don't be afraid to ask questions on that WhatsApp group. And if anybody ever gives a rude answer to a question, they will be dealt with. Okay. So Nadia did K and N with you guys. Let me share my screen. And on that, I'm just going to give you guys the warnings of being in my class. The first thing is I can be pretty reckless when I share my screen, and you can see stuff that has nothing to do with your lecture. It's never traumatic, but I do apologize. While we're talking about this, there's something wrong with ARC, and both me and Nadia got kicked off ARC today. So what I'm going to do right now is I've shared the slides on the WhatsApp group already. We were asked this afternoon, but I'm also going to put a link to all the content that we're using tonight here in the chat so that you can find it. And I will keep updating that OneDrive as well for people who have access issues. But I'm sure Nadia and I will be probably back onto Smart tomorrow. I normally like to build you a nice learning unit in ARC. We don't have that tonight, but we don't need it. Okay, so Nadia did K and N with you, which is like the gentle introduction to statistics and machine learning, and to show you that actually it is that easy. It really isn't that hard. We just measure the distance between flowers and then work out the average. Okay. So today I'm going to start with linear regression, and this is the only time I'm going to say, no, listen to me. So now listen to me. Linear regression is going to follow you. The equation of a line in linear algebra is throughout. So Nadia, where do you see it? Where do you see it? Do you see it in logistic regression? You see it in ANNs. Where do you see y equals mx plus b? I put no idea on the spot.
I see it especially in linear regression if you're doing predictions as well. So predictions, linear regression, logistic regression with a few extra variables. So you see it everywhere.
So this, yeah, take the time to learn this, because if you've got this, you'll be okay. So this is, when they talk about the foundational thing that you need to know, this is that foundational thing. And that is why, hi, that link said does not. What did I do? Oh, I didn't click done. Let me say this. Sorry, apologies. And yes, I'm always like this. Please try access the link now. Okay, so take the time, and that is also why I'm going to be methodical and slow tonight. So if you are someone that has done stats before and you're like, this is easy, then feel free to take the notes, drop off and read them. My focus tonight is to embed this properly. So if you're someone that understands the equation of a line, I'm going to start from grassroots levels and work nice and slowly through it. Bianca, can you still not access that link? Bloody blink it.
You can access it now. So just refresh the page.
Okay. On that note, let me share my screen and get my bearings together. I am Afrikaans, so the Afrikaans is going to come out in the way that I might mispronounce words and I might slur some words, and I promise I haven't been drinking. I'm just Afrikaans, like very Afrikaans. So that's the one thing. And then for the couple of days that you guys have me, I'm available on WhatsApp, but I am forgetful. So if you need something from me, please don't be afraid to ask until you get it. Okay, don't be. I am unfappable. I'm unirritatable. I realize my limitations, and I would never go like, you message me 9 million times. I'd rather be like, oh gosh, here's your link. Okay, so if you need me, you need to hunt me down. I will never ever be mean to you. Okay. And the other thing is that if you message me after 9, that's not good. Okay, I have children, and that is like, I will have them phone you. And one is a teenager, and you will not be okay. So I'm not really contactable after 9, but anything up until 9 o'clock at night, you're very welcome to contact me. You're very welcome to WhatsApp me. Please, email is really tricky because I work, I do a lot of field work, which is why I'm currently in Cape Town conducting research. And then I've always got my phone with me, but I don't have my email with me. And sometimes in like weak signal settings, the WhatsApp will come through, but the email will not. So if you email me, you are going to get a delay in response. If it is something super formal, I will reply on WhatsApp, and I will ask you to follow it up with an email so we have an official mail trail to keep you safe. But the best way to get me is WhatsApp, and I don't work normal working hours. So up until 9 o'clock, you can find me. Sometimes if I don't respond to you for 2 or 3 hours, please do remind. Don't feel afraid to do that. But I'm just on a research site, and sometimes I don't have any signal, and sometimes I'm in the middle of a session. Okay. Are you guys happy with that for the rules of engagement? Nadia, we have someone that missed last week's class. Do you want to, because Nadia taught last week's class, do you want to pick that up or not?
It is recorded on YouTube, and I did share the link on the WhatsApp group, but I can quickly share the link here as well because it is all of the recordings are going to be there. Okay, so let me just find that link and share it because all of the recordings I will be sharing on the YouTube playlist. So all of them will be there.
So we start a YouTube playlist, and we also, when our ARC access is sorted out, we will, that YouTube playlist, as we upload videos, the YouTube playlist will just update. So you just have one place to go and look for your video content.
The YouTube playlist should already be there, except if someone undid what I did. So I did put the YouTube link on there, I think, for group 1 and 2. Group 3, I was busy with yours and then I got kicked out. So sorry about that. We will get it fixed.
Yeah, and we'll get our ARC access back. It seems like they run an update and then we just got kicked off. Okay, so and Nadia, just that I will give you editor right on that Google Drive if you want to throw the KNN slides on there as well and your KNN Excel sheet.
Perfect.
Okay.
Thank you very much. Okay.
Okay.
I'll drop off and I'll see you guys again.
Okay.
I
Bye,
am
Nadia.
available on WhatsApp if there is any problems as well.
Okay, and
bye
Nadia
everybody.
runs tutorials. Okay, so let's
Yes.
talk about what we have to do today. So in SMAA, we're currently working through Learning Unit 1, Chapter 1, which is supervised learning. And then with Nadia, you guys would have done the bias and variance trade-off. You might have talked about, we'll address all of this again tonight. You might have talked about over and underfitting. Then you did k-nearest neighbors, which is just such a beautiful little algorithm. And tonight we're going to start with linear regression. Okay. I will pop in and out of the slides to check on you guys. All right, so the learning unit outcomes for this learning unit is basically apply mathematical concepts of linear models and the least squares approach. So explain various variable types, which should have happened in learning unit 1, but apply the mathematical concepts of linear models and the least squares approach is what we will be doing today. We'll be talking about today. You guys did apply the k-nearest neighbors with Nadia. We'll be looking at what higher dimensions is, and that's such a bloody, if you read that thing, you're like, what is that? It's really simple. And then we're going to look at the bias and variance trade-off once again. You will have discussed it with Nadia, but we're actually going to look at it in shrinkage models or in how it's applied to linear regression. And if I say big words and they freak you out, just go like, Serena, stop with the jargon. A shrinkage model is just how we see our model is not doing so very well. It's a way to make our model just do a little bit better by just taking a little bit of a where we compromise. Okay. So we know that machine learning is classified into 2 different areas. There's unsupervised learning, and you guys will deal with unsupervised learning in PDAN. We don't really do a lot of the stats for unsupervised learning, except maybe neural networks, but a neural network is either unsupervised or supervised. Okay. Then there's classification and regression. So classification is where we say a thing is a thing. It is where variables are discrete. You're not 30% flower, you're a flower. Well, the stats can be 30% flower, but we classify you as an iris, as a sesota, or as a versicolor. And in this data set, we're going to classify you as a bream or some kind of fish. Okay, and then regression is the other way. Regression, so linear regression, is where we're looking at predicting either a number or a floating range. So predicting a house price, that's a number, predicting things. So it's not a discrete thing like a class. It's more working with a range of numbers that can be fluid. All right, so what you're seeing in front of you is data points. Okay, so this can be data points for mice or ice cream sales, hot days. Okay, this could be data points for Bridgerton and views on Netflix. This could be data points for anything under the sun, and these data points are just plotted, and this is a 2-dimensional space. But even though this data is scattered, it's not a straight line, but we can actually draw a line that makes us fit or find the best fit for the data points. So we have 2 tools to draw this line with. And how we figure out where it's the best place is we actually measure how far it is from the data points, which is called residuals, but we'll talk about that in detail. For now, what we're going to focus on is how do I draw and move that line? So we have 2 things we can do it. It's the y-intercept. So this in any chart is your y-axis, and this is your x-axis. I almost said z. Z pulls out this way. And your y-intercept is the angle of this line. So if we cut at 0, the line is quite steep. Okay, not the angle. Well, yeah, the line is quite angled. But if we cut over here up the line's angle becomes a bit less. Okay, and then we have slope, the steepness. So we can cut at the y-intercept. We can still cut the y-intercept with the line here, but we can have a very unsteep line that comes over here. We can have a super steep line that goes up that way, and then we can have this line that goes this way. So those are your 2 things. Those are the knobs you have to turn your line to make it fit this data. And that's all we actually want to learn in linear regression is what are these 2 places? How do I draw this line? And those are the variables or the coefficients, which they are actually called, that comes out of linear regression. It's literally, where do I cut it? on the y-axis and how steep do I draw it, which is your slope and your intercept. Okay. So there is something known as the equation of the line, and it will be with you throughout linear regression, throughout logistic regression. You will see it in neural networks. You will see it in gradient descent. You will see it everywhere. Okay, so how do we find the equation of a line? Okay, so just so you guys can know, whoopsie, the equation of a line, why is this laptop doing this? The equation of the line is y equals mx plus b. Let me go find you guys and look, eyeball your little spots. So what do you guys think y means in the equation of a line, and what m and x and b means? Does anybody have any idea what y equals mx plus b means? You can type it in the chat, or is that like a horrible thing to ask you guys? M is the gradient. Yes, Kurtley, Manyabi, you guys, your hands are up. Is there another word for gradient?
I'm not really sure, but I do know what the equation means.
So tell us what the slope. Yeah, good job. What does the equation mean?
It is, your m is your slope, your x is your independent variable, your b or your c is your y-intercept, and the y is the variable that you're seeking to find.
That is an excellent explanation of y equals mx plus b. Okay, so yeah, that is exactly what it is. So y is what we're trying to predict, or the variable you're trying to solve for, and m is your one knob, and b is your other knob. Okay, so here you will see we have your y-intercept and your slope. Those are the two knobs we can turn to try and find the y variable, but we do need the x value. We do need these readings here at the bottom, and you find that in your data set that you use for training. So if we wanted to know for when the dates that Bridgerton is, we would have the dates, or the dates that a series is. But say we wanted to know how much does the viewership for Netflix go up when Bridgerton is, we would have to have the dates here, which is our x variable, which is our independent variable, and then we would have the dates plotted here that we can have a look at, or the viewership numbers, and we can then solve for how much does it go up. Okay, so that very simply is the equation of a line, but you will see it in many shapes and forms, and I was lacking the explanation given there because there is the mathematical equation and the statistical equation, which sometimes confusions. This is where the Afrikaner comes out. Okay, it sometimes confuses people. This is the mathematical equation. Okay, and you find the one you love, and you love that one, you can't go wrong. However, this is the statistical equation, and it's the exact same things. Just why statistics and mathematics people do this is an excellent question, which I cannot answer you. But here's our prediction. Your slope can also be a w. Your x will always be your x, and this just means various x values. Okay, and then and I'll show you what I mean with that in a second. And b is your intercept. You can also see it this way, where it shows it to you in vector format, and then you're like, oh my God, what's happened to my life? I want to die, this is difficult. It's not. This is all the same thing. I want to open an Excel spreadsheet and just show you some things. Okay. And remember what I said about the trauma. I'm sorry for the trauma. Sorry. Okay. So if we're going to go look at this little linear regression spreadsheet over here that I gave you guys, and there's many pages, for which I'm sorry. Okay. So if we're going to look here, I've given you all of the formulas in the spreadsheet, everything you need to look at, descriptions, all of these things. So this is fishies. These are breams, okay? And we have the breams' lengths, their height, and their width. Okay, and we can decide what we want to predict from this data. All right, but there is many fishes here. There's not just one fish. So y equals mx plus b is one fish, okay? Then this, if we did for this bream at number 8, y equals mx plus b is 1 fish. Okay, problematic. We don't just want to work it out for one single fishy. Statistically, y equals w times x plus b is 1 fish. But if there's multiple fishes, we just show them like this. Okay. Or you show it that there will be multiple w's and there will be multiple x's. That's just saying this is a vector. It means a whole table in simple speak. That's how they show you. That is most definitely gyroscope data. Sorry. It just tells you that that is being applied to the formula there. This dude. Okay. This tells you it's this entire table. It's all from 0 because we start counting in 0 in mathematics and programming. All the way from 0 down, it's the w's. All the way from 0 down, it's the x's, and there's only ever one b. Okay. So are you guys okay with that? That it could be y equals mx plus b. It's one variable. Or we could also have y equals w times x plus b. And we can also see it in vector format. But that's all the same thing with the exception that this is just one. And you can also see it written as a loop. And I'll show you an example of that as well. So you can see that formula in many ways. I actually think I have the loop formula on the beginning slide, but I must just always check. Yeah, but that also has the loss in it. So let me not break you. All right. So that is very simply put the equation of the line. So let me go back to my slideshow. So here we have an example where we have, where did my mouse go? Oh, here you can see our intercept is not dead at 0 because the intercept is not always at 0. However, if the intercept is not given, we assume 0. And then w, and just remember that the thing is backwards. Okay, so if you see the thing in maths and you can't remember what it is in stats, just turn it upside down. Okay, so the m is a w or the w is an m. Just invert it, and there's always the given value x. So y is what we're trying to solve for. B is our intercept. That m can flip around, and x is our given value. All right, that is the equation of a line. So why do we use it to predict things? I mean, that's why. So before I show you guys that slide, why can this formula, why do you guys think, or who of you know, where are you people? Who of you know how that formula is used to predict things? Why can we use it to predict things? Does anybody have an example? No, nobody said I was going to be asking questions, nay. Nobody? Okay. Did I miss any? Oh, Kurtley, please go ahead. And I'm sorry if I've done bad things. Oh, I'm seeing the hands pop up. Okay, first one that wants to go, run. Tell us why we can use that for a prediction. So now we have multiple hands and no one wants to talk.
Okay, I'm gonna try, ma'am. I'm gonna try.
Try, yeah.
Okay, so in a graph you would get a lot of data points, and then in Afrikaans you call it the lyn van beste passing. So it's the line that fits the best between those data points, and then the next data points you can predict how far from the line of best fitting it is and predict its position.
A beautiful explanation. Is there anybody who wants to give us the line for beste passing in English? What is it called?
The line of best fit.
The line of best fit. So if we know how things move up in a direction, we can predict. So if you know, for every one pencil, and this is like I said, remember, if you are a stats pro, you're going to have to either log off or go through this because we have to get everybody to the same page. But if we know, oh my word, I'm so bad with slides. If we know for every addition, every time our pencil sales increase by 1, the sales price doubles. So 1 pencil is 2 rand. 2 pencils is 4 rand, 3 pencils is 6 rand, 4 pencils is 8 rand. There's a pattern here. So, and we have these values at the bottom. So if we want to figure out what our sales price is, we can easily be like, okay, so for every 1 increment in the bottom here, we go up 2 at the top there, known as your rise over run, and which makes this a deterministic model. So we can determine the value of S, our sales price, by supplying X. I've put some links here for you if there's other little things you want to go look at. The Maths Are Fun for Math is Fun is a really nice, very plain English site to explain this to you. And then there's also how they use the linear models in the basic statistics links there at the bottom. So if we know if I sell 1 pencil, it's my sales price is 2 rand. Oh, cents. Sorry, no, rand. Who sells pencils for cents? If we sell 2 pencils, it's 4 rand. If we sell 3 pencils, it is 6 rand. So if I then go and ask you, okay, what will it be if I sell 8 pencils? Then we will know S equals 2 times X. And then it's deterministic because S depends on S. S depends on X. So we can easily use this line to make predictions because we're actually following a very clear pattern. So this is a perfect line. Actually, this is overfitting like you can't believe. This is a perfect line. Obviously, our lines are not this perfect, and there's ways we deal with it, but we can in our data. So if we look, I want to see if I have something like this. No, thank you, AI. We're okay. So if we look at this plot, we can actually see the linearity there with the naked eye. We can see that this data is linear and we can draw a line. And if we have that line, we can make a prediction. We will have some error rates because the prediction won't be perfect and we'll account for that. But we can see that we can look at for every increment in X, how much does Y increment? And we can then just use it for a prediction. So it's literally that simple. Okay. So in mathematical terms, and how you're going to hear these things described, so rise over run is a very American term, but it's a nice one to remember because this is your run, like you run forwards and you rise upwards. So if you get confused about what to work, you just always look at your chart and you go like, okay, so I run down flat in this direction and I rise upwards. So that's your rise over run. So if we wanted to calculate Y and we had these things, okay, so we can find any point on the line. You draw a line down from that point. No, man, why is this machine doing this? It's this new mouse. We draw the line down from that point to the x-axis. You find your rise over run. What is 6 divided by 3? It is 2. So then we know for every 1 incrementation in our run, in our x variables, y is incrementing 2. So then we can know if at 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So if you want to know what 5 is, 5 times 2 is 10. It's that simple. And you will not believe how much of the machine learning statistics relies on this simple way of doing things. So there is an example for you of how we work it out with mx plus b. So if we now take away that, we can just do the up and down stuffies. If we say y equals mx plus b, so then we go say, okay, we have to calculate our slope. So find our rise over run, 6 divided by 3, that is your slope. So y equals 2 times x plus b. X is always given to us, so we choose any one of these points. And then if we wanted to know 4, 5, y equals 2 times 5 plus 0, because our intercept is at 0. If our intercept was 0, it would have been 6. Then if we wanted to do it for 20, it would have been y equals 2 times 20 plus 0. And we would always find that y variable. So let me come check on you guys. Those of you that wanted to math vomit when we started, does everybody want to vomit? Anybody else? Yes, Kirtley, please feel free to talk. And then I'll answer Kirtley's question. Kirtley, your hand is up. Please tell me how to pronounce your name if I'm doing horrible things to it.
Oh. Okay.
Yeah.
I just wanted to know, you asked the question, why do we use a linear equation to represent the linear regression? Is it okay to say that the reason why is because the gradient value in the linear equation is a relational value in that it calculates the relation between the y and the x value?
That's a perfect thing to say, because you can say that here the relationship between your y and your x values is 2. That's a relational. So for every 1, so describing it in relational terms is for every 1 increment in x, there is a double increment in y, and that is relational. That's completely correct to say it. And this applies only to linear data. So we can definitely apply the equation of a line here, but we're going to have a bit of a tough time with this, dude. There, you're looking at a whole different way, and there's different algorithms that we will use in that regard, and you'll learn all of them. But one thing, there is a rule, and in the PDAN assignment, in the data science assignment, in the programming assignment, they are going to ask you, why do you know this data is suitable for this particular algorithm? Is to check for clear linearity. So even here where we have linearity, things are a bit mixed up, but looking for clear linearity in your data. Okay. All right. This is the simple math formula that we use, but it does have another name. So what happens is, this is fine. Y equals mx plus b is fine for one thing. I mean, working it out for pencils, no problem, but we just have one feature. So looking at these fishies, how many features do you guys think we have in this data set?
We have 6.
Let me count them. 1, 2, 3, 4, 5, 6. Yes. Oh, this math is going to be a problem. We have 6 features in this data set. So observations are columns. Every single fish is an observation, and the features, how we describe that fish, is observation. Rows are observations and columns. So we have 6. So now, how do we y equals mx plus b here? What do we do? How do we work out? Do any of you guys have an idea? So if we have one feature, we can work out one y relative. So if we have one feature, we can now come to, I have to stop showing you gyroscope data. If we have one feature, we can now comfortably say, predict the fish's width based on its length. Okay. But what if I want to add this third feature? What am I going to do then? How do I y equals mx plus b then? So if we go and say, in this example, we're predicting weight, and that becomes our y, and this is very much a prediction of weight when we go into it. If we want to predict weight, and that's our y, and if we have one feature and we only use, say, height, but now we also want to use width, because it's like just one feature is not enough. So, and it doesn't describe the data completely. So what if we want to add width? What do we do then? Any takers who's going to tell us as a class, what's the next space? What's the next thing we do? What do we do when we end up in plus b? Now there's y equals mx plus b. What do we do then? And then quickly, yes, we predict future values based on the previous results if the trend continues 100%. And that's why it's called regression. We actually work backwards to what happened in the past to predict the future. So can anybody tell us what happens when we start having more features than just one? Any takers?
Is it when we start using determinants to try and get one linear one linear equation to represent all the different features?
100%. We use determinants. It has a name. Anybody that wants to guess what that name is? Yes, man. Ooh, Manya. Is it Rafilia? Manya Pape? How do I say your name?
Hi everyone. It's pronounced phonetically, so it's Manyape. But I do
I
go
won't
by
stuff it up again. Okay. Yeah.
but I do go by Refilwe. I was actually in the process. Oh, and hi everyone. I was in the process of lowering my hand because Kirti kind of said what I wanted to say. That once we have more features added on, he did mention the determinants, but we literally just add that into the formula. So we'd literally have like maybe the first mx plus c. Well, the slope and the x representing a certain feature, and then we just add on for the next feature, like the particular gradient and another variable, maybe b, and stuff. And then it should account for the different features, I presume.
Yeah, okay. Yes, you guys are an excellent class. I'm going to have a very easy semester. I'm looking forward to it. Okay. We use something known as ordinary least squares. Okay, and we're going to talk about ordinarily least squares in detail, and we're going to work it out in detail. Please don't freak out. So before we go into how do we calculate with those many variables, I'm going to show you a small example in Excel where we've actually used all of these in our equation. Okay, so if we go look at our OLS calculation here, we actually work it out for all of them. Okay, and I will talk you through it very nicely how that works, but you're going to do the mx plus b for each one of these. So I'm going to highlight this so we can actually see what we're working with. So you're going to say, you're going to do the y equals mx plus b for each one of these and just gradually add them all together so that they each count for their value. But we'll work it out together as a class in this Excel format. So don't worry. And I have very nice examples and step-by-step through for you, but don't stress. Under the probability and the log, I will explain all of it in great and careful detail. Please don't get scared. But if we wanted to predict the species, so we wanted to predict the likeliness of a species, based on its weight, length, height, all of this, we go and we say, okay, we're going to take this guy times mx plus b, this guy plus this guy times mx plus b plus this guy times mx plus b plus this guy, and you see it here. Okay, that will work out the like OLS for you. So why is it called ordinary least squares? Where does that come from? So ordinary least squares comes from this. Okay, so when we draw that line, if we cut through all the data points, it's actually not good. Even though it seems like a super duper idea that we cut through all of those data points, it's not, because if we cut through all of the data points, we have learned that data too closely and we are overfitting. Meaning if it sees another guy, it's not a record that it's never seen before, an unseen observation. It's going to make an error. So what ordinary least squares is, we draw the line and then we find the residuals. So the residuals is, how far is the line from the data points? These little red guys are your residuals. Okay, so we want to find, and we want to minimize these residuals. Where does the squares come in? Sometimes they might be exactly opposite to each other. Okay, so you might have example +3 and -3, and then they cancel each other out, but that doesn't happen if we square the value. So we actually just square. So if we say that we were going to say, this is where we drew our line, you're going to minus the data point from the line, the actual value from the line, and find that residual. And we just square it so we don't end up with a negative, so that we cancel each other out. And then at the end, you're basically just going to take the total of all of them, and that's your error rate. And you can take the mean. Let me not get into error rates. But basically, we want to find the line that reduces this error the farthest by possible, and that's why it's called ordinary least squares. And ordinary because it's the most basic ones. Okay, we want to find the line that minimizes the area of look at this. We want the one that minimizes the sum of squares. Okay, and we're going to talk about the way we do that and how we evaluate in detail, and we'll work it out. But we want to draw the line where if we find all of these residuals, we square them and we add them all up, that we get the smallest possible value, because then the line is as close to the data. That's the line of best fit. And that's why it's called OLS. And then why do we scare? Because we're going to end up with very small numbers or zeros, and they're going to cause a problem. But if we square something, it's always positive. Okay. All right. Now, how do we calculate the sum of least squares? Then we're going to go play with some Excel. Well, you guys are, and you're going to come back to me. Okay, so how do we calculate the sum of least squares? Just back to what I said earlier, if we have two features for crazy and hot, and this, I don't actually know why I used this example, but it's stuck. So the hotter people are, the crazier they are. So basically, the better looking your significant other or flavor is, the hotter they are, the nutsier they are. So you have to decide what you want. You want hot or crazy. So for every increment in crazy, there's several increments in hot. That's just two features, hot and crazy. But what if we add a third feature in this hyperspace? So this is a what? You can tell me what's the difference between this, and this. Okay, I wrote it there. That's not very clever. So what is this? What is this? And what is this? Who knows what those three, except for the hyperplane, because I wrote it there. Who knows what those things are called? Let me find you guys slowly. What are the differences between those three pictures that I just showed you for ordinary least squares? Yes. Your hand was up. Or it went back down.
Oh, sorry. I think my lower hand feature, like lowering the hand, is a bit delayed, but I'm not too sure what it's called. But I do know that the X, Y, Z are in different planes, but I don't know if there's a particular name for that.
This is just a line. This is a plane, and this is a hyperplane. So when we have all of these density, when we're adding this, so one feature is just a line. Two features, you're looking at a plane, still manageable. It's when we hit the 3D space. But when we get here, it's a hyperplane, and now it's all. And now it becomes difficult, and that multiple 5-feature thing we saw is in the hyperplane space. And when they talk to you, when they show you this module outcome and you read it and you're like, what in the actual hell are these people talking about? Apply local methods in higher dimensions. That's all it is. It's all, and I don't know why math people come up with these bloody complicated words. That's just higher dimensions. This is the higher dimension. It's not one-dimensional anymore. It's 2-dimensional or 3-dimensional or a hyperplane. And a hyperplane is this. This is a hyperplane. This is when we have these many, don't break your stuff, Serena. It's when we have these many features. That's what a hyperplane is. So when you see that kind of stuff, you don't freak out. You go like, oh, it's actually just a data set with multiple features. And we can't just y equals mx plus b, because we don't just have crazy and hot. And we can't just crazy, but even if you want to do crazy, hot, and available, you're entering 3-dimensional space. And then we have to calculate things a bit differently. And that's why y equals mx plus b becomes a problem. Then we find this. And this is how we actually get this back to yx plus b. Now, we're going to talk through this nice and slow. All right. So in this guy that we have here, in this duty, and we will talk all about this. We'll go slowly and we'll work through all of it. I've done this for you guys, and we will, like I said, calculate all of it. So this is basic OLS. So basically what you're going to do, and this is the example from the slides that I've given there, and this is OLS. So how do we do this? So we're going to look at this table here. We're going to flip between the table and the slide and look at the calculations, and then we're going to go calculate this. But you guys are also going to help me. It's not just me suffering alone here. But here are the steps that we take, and this is directly taken from that slide. Okay. So we need to find determinants. We need to find a generalized, if you want to use that word, slope, and a generalized intercept that we can use. And then we can apply it to the different x values. So how do we do that? So for each x and y point, you calculate x squared and x times y. Then you sum all of the x, y, and x squared and xy, which gives you ex, ey, ex squared, and the sum of ex, y. Then you calculate the slope of that, and that's still just your rise over run. Then you calculate the intercept, and then you assemble the equation of a line. You just built that line. And actually, that's not very hard to do at all. So let's look at this example of how we did it. Okay. So if we look here, we have our height and our weight. Okay, so x, we're only dealing with two variables, these two little guys, and we're predicting the species. Okay, so we're predicting based on the height and the weight of a fish, and you will see if I've done my job correctly, we will have only one species here, but you can have two. But based on the height and the weight of a fish, how likely is it, or what is the prediction that that is a bream? Going to do this, so what we do is we follow this very, very carefully. Okay, for each xy point we calculate x squared. So we go and we say, okay, where is our x point? Well, here is each x point, and we're going to go and square each of them. So if we look at this guy, if we take just height, okay, we're going to go work out x squared. So there in V number 8 is our height. And this is a simplified example to start with, so don't stress out if you're wondering there's multiples, what do we do? So we take that height and we go say, okay, let's work out our x squared. And all we do here is square it. For each single one of these heights, we square them. Okay, are you guys okay? Oh, we actually can't predicting the weight, sorry. Then we say for each xy point, x and y, calculate x squared and x times y. So we make this table and we go calculate x squared and we go calculate x times y. And we can see that we're doing it with these two. So if I click on this guy here, you will see it is this number squared. And if I click on this guy here, first I'm going to break everything with this blinking keyboard. You're going to see that that is literally just x times y. So we calculate that first. That's your first thing. Next thing that they're going to ask us to do is sum all the x, y, and xy values together. Okay, so if you look at this, we are looking for, to do this calculation, we are looking for these guys. Go work out x2 and xy, all right? And then sum all the x, all the y, and all the x2 and xy values, which gives us the sum of x, the sum of y, and the sum of x squared, and the sum of x times y. So that looks super difficult. It is not. I opened the wrong sheet. Okay. So we go work at the bottom here, and we go like, okay, there is the sum of x. Okay, the sum of x. And this is just an YGRAC or whatever you want to, like, it's got many names, but it just means the total, the sum of x. This is the sum of y. Okay, super difficult. Don't know how you guys are going to cope in this school. Then the sum of e2 and the sum of xy. So literally we just go make a table and we say, okay, I'm going to square all the x values. I'm going to time all the x and y values together. And then yeah.
Oh, yeah.
Yes.
Do we need to see the Excel sheet?
Yeah, are you not seeing it?
Now we can see it, yes.
So what are you guys seeing? Okay. Can you see the Excel sheet now?
Yes, we can see it now. I'm not
Yes.
sure if it's my Wi-Fi, but there's a bit of a delay.
Okay, let's wait till everybody can see this sheet. Is there a delay for anybody else? Because like I said, I am absolutely not teaching from home tonight.
I
Yes,
think it is lagging a bit.
there's a bit of a lag, and I think it's on your side.
Okay, now what I'm going to do is I'm just going to hotspot a phone. Can you guys give me 2 minutes? I might drop off and drop right back on, but let's just not use this and use this. Okay, am I back? Can you guys hear me?
Yes, we can
Yes,
hear
we
you.
can.
I had a
Yes, we
question
can hear you.
maybe.
Is the lag gone? Can you see me move my mouse around?
Still lagging a bit.
Yeah,
Okay,
it's still
so I'm
lagging on my
definitely-
side as well.
That's wild because I'm on 5G, so there's no way this should be lagging. Okay, shout when you can see the spreadsheet. Which means I can't see you guys right now. I'm seeing what you're seeing. Do you see the spreadsheet? You can also open the spreadsheet on your side, hey?
We can see the
Yes, we
spreadsheet.
can see
Yeah,
it.
we can see it.
Okay, so can you guys see here we have height and weight? And can you see that we worked out x, the height squared? And then we took x times y, which is the x and y values times together. And can you see that at the bottom, you just sum them all? Can you guys see the sums here?
Yes, thanks.
Okay, all right. So what we need to do, the calculation is here written for you. For each x point, calculate x squared and xy, x times y. Sum all the x values, sum all the y values, sum all the xy values, which gives us the sum of x, the sum of y, the sum of x squared, and the sum of x times y, or just let's write it as ey. Okay, So if you look where I'm getting these values from in this little table, can you guys see the table? Yes.
Yes, ma'am.
Okay, so you're okay, and there's not too much lag, you can follow? Okay. I'm not ma'am. Ma'am is my old English teacher. Okay, but these values are coming from here. So we've done this little calculation where we've squared and we've timed, but there's the sum of x, 531.2124. It's just the sum of x. So if we look, that is 100% the sum of x. The sum of y is over here. If we look at that value, we've gotten it from W34. If we go down here, this is literally just the sum of y. 21624, 21624. The sum of x squared. So those are the building blocks for your formula. It's 8199789. You'll see it's the same here. And the sum of x times y over here is this massive number here. And that's going to come up there. And then we just need our number of observations. So we're just going to do a count of the first column. And it's going to give us that there's 35 observations in this table. These are our building blocks to build that one slope and that one intercept to get us back into y equals NS plus b. And this is the formula, if you see it here. Okay, and then what does that formula mean in English? Okay, so if you look at the formula and you're not a formulas person, but I'm hoping at the end of this course you absolutely will be a formulas person. But if we look at this formula and we have a look, we can say, oh, what does this mean? Well, okay, let's not do this. It means take the number of observations, 35, and there I've typed it out for you guys, okay? And the top line, take the number of observations times with the sum of xy. So the number of observations is 35 times the sum of xy. Subtract from that minus the sum of x times the sum of y. So subtract from that the sum of x times the sum of y, which we've worked out here. Then at the other line, we say take the number of observations times by the sum of x squared. And if we go look there, there is the sum of x squared where I'm getting it from. That's why I typed out the amounts for you guys to have a look, but we also do it in the formula, minus the sum of, okay, so divided by the number of observations, the sum of x squared minus the sum of x squared. So we just work this out and we get these answers. So if you're going to go look at it over here, it is 35 times this value over here. And you see that this matches that formula n, 35, n, times with the sum of xy. There we go. If we find the sum of xy there, that's the value we see over there. So what that gives us is these two big values. If we work it out, if we subtract them from each other, we end up with the two values we have to divide from each other, and that gives us our general slope. So to calculate the slope, this is the formula, and we will do it together, and that is the formula broken down in plain English. Okay. So, and this gets a little bit confusing in my writing here, where I say take the number of observations times the sum of xy minus the sum of the x times the sum of y. So I don't know why they don't put times signs and formulas for you, and you're supposed to just know this is times, but that's what that means. At the top level and then at the bottom, divided by, that's our line in the middle. We're going to take the number of observations times, so the number of observations times the sum of x squared. And then where it gets confused, minus the number of observations of the sum of x squared. So what does that mean? We actually have to square ourselves. The sum of x squared is this, where we've taken x, we've squared it, and we've added it up to each other, minus the normal sum of x, where we have just calculated x, and then we square it. Okay. So here is the line again. So it's going to take, say, take the number of observations, 35, times the sum of xy, times this 341,800. Okay. And then subtract from that the sum of x, there it goes, times the sum of y. That gives us this number. And then if we do the bottom of the line and we take the number of observations, 35 times x squared, so 35 times x squared, and then we do the next one, the sum of x, this guy, and we square it. We get these two numbers. It gives us these two values. If we divide them by each other, that is our slope. Okay, and then here it is in an Excel formula for you typed out, which we're going to work out together in a couple of minutes. But that's just how we calculate, because we have this guy here. I mean, we've got this guy that we're going to clean out and we're going to work with now. We're going to delete all of our stuff here and we're going to do the calculations together so that we know how they are done. Then we obviously need more than that. We also need the intercept. So how do we calculate the intercept? So what does this formula say? Well, this is a lot easier. Okay, so to calculate the intercept, we need the exact same, guys. Okay, so to calculate the intercept, we take the sum of y minus the slope we just calculated. And you can see we calculated that slope at 102.704 minus the slope that we calculated times the sum of x divided by the number of observations. Here I've broken it down for you step by step, which will give us our slope, which in this case is negative. And we will use that to make, like I said, we're going to do it together as well now. We will use that to do our OLS. So if we look at this OLS calculation, if we want to see what values am I using, I'm taking the height times by, 1 second, that slope we've calculated plus scroll, man. That intercept we have calculated ourselves, and that's a basic OLS. We will also do one with multiple features, but we're going to start just working with one feature so that we're comfortable, and then we're going to go to physiologistics and work out the OLS portion, which is all the features. So let me just find you guys. Does anybody want, quickly, does each X point mean each feature? It means each X point is each observation. What am I saying? Ask me in words. But before we do that, yeah, Ulrich, I want to know how you guys are feeling. Yeah, Ulrich, please ask.
Okay, so I understand everything we did here with regards to the formula, but I think I'm a bit slow when it comes to, if we look at M, right? So that formula, I don't know how to phrase this now, but is it like something that we just need to dummy study what the formula is, or is there a reasoning behind the calculation in order for me to better understand why we're doing the calculation like we're doing it, or is it just I haven't been in maths for too long?
Ulrich, there's no such thing, you haven't been in maths for too long, so I'm going to answer your question and then I'm going to come to the other two. Okay, why are we doing that calculation? I'm going to go back to these slides. When we do this y equals mx plus b, so y equals your intercept times your x variable plus your slope times your x variable plus your intercept. When we do this calculation, we can do it for only one single feature. Okay, so, and we're starting with one single feature just to make our lives a little bit easier, but we can only use one feature in our calculation. So in this one, we literally are only using height. Okay. But there will be instances where we actually want to use more than one feature. So for this one, in this example here that I'm looking at, is we are saying we're taking the fish's height to predict their weight, and we're using small features here just to get to grips with the calculation. Okay. When we go and look at this calculation over here for physiologistics, do you see that each one of them has their own slope? Okay, their own. So what if we wanted to predict a species? But to predict the species, we needed the weight, length 1, length 2, length 3, I don't know what they are, the height and the width. And we're predicting a species by seeing how close we get to what they agree with here. Okay, so we're rounding that into probability and this is like logistic regression. We'll talk about that, but we want to see the percentage chance or the probability chance that it is this species. So you can see it's RLS because it's this ranging number, and this is 60%. The thing is 60% sure that this is that species of fish. When we need to use more than one of these guys, that's where it gets a little bit messy. Then how do you work out y equals mx plus b? So where do you find the slopes and the intercepts? How do you do that? Well, oopsie, let me just go back there before I fix it. Then we have to find a generalized slope and a generalized intercept, and we calculate that by using generalized or to the one that represents, because after you're going to look at that, a lot of that is calculating average, but we have to find one slope and one intercept to work with that represents all of these data points. That's why we do this calculation. If I go back to this slide, so we ended this slide with if we are in the hyperplane space. So here, y equals for every increment in x, okay? We will times that by the slope plus it by the intercept, and we will get our values. It's very simple to predict just hot from crazy. But when we have more variables in the mix, like if we're trying to predict available from hot and crazy, then what slope do we use? Do we use this slope? Do we use that slope? We now have three things. Which one do we use? And what do we do if we hit a hyperplane space? And that could be something like genetic markers, where you're looking at 45, 60 variables. Then what do we do? Then we come to this. How do we y equals mx plus beta? How do we still use the equation of a line, which we saw here how easily it works? How's it going to work over here? So what this does is this allows us to work out the slope that represents all those features. And it allows us to work out the intercept that represents all the features that we're working with. So we can get back to y equals mx plus b. So that's the reason we do that equation. That's how we get to ordinary least squares. But there is a caveat to it, and we'll work up to it, is that we'll actually work out this is the wrong one. We'll actually work out the y equals mx plus b for each feature, but we can't use different ones. We have to know what we're doing. We have to have the calculation to work with. So I think the best way to do this is to work it out. Okay, so you can see how we use it. But that is just to get the ordinary least squares calculation to have one slope and one intercept. In truth, in machine learning, you're going to have, but I don't want to confuse the living heck out of you. So let's just stay with that for a minute. How do we find for all different features, but also for different observations? How do we find the x and the m and those values to work with? That's what this calculation gives us. It just brings us back to y equals mx plus b, because now we've taken all of these observations and we've worked out our slope and our intercept, so we can apply that formula in higher dimensions. Did that help you guys, or did I just make it infinitely worse? Still at the
Can I
yes,
maybe
JC?
come at my end? Yeah. Okay, look, I think I'm at the same space where the previous speaker was. Remember when we did the Pythagoras and we could almost make sense of how we want to get to maybe the length. In the same way, we were getting to the gradient on the more simpler baseline, right? On the simpler equation. But now, okay, we've got a couple of features. But right now, the way that we were trying to work out this value is like we are still working with one feature and one y value which we're trying to predict, not yet going to the multiple ones. So maybe what I'm failing to understand is the same thing. Okay, yeah, maybe what I'm failing to understand is there a way of explaining this to say, like you said, if we just need to get this formula and use it, yes, we can, but it's always better when we understand exactly how is the gradient coming out of this formula. Then it almost makes sense for us, just like with the rise of the movement kind of thing. Yes. So can we get a rise of a run kind of explanation with this formula, or we don't need to do that?
Yeah, you're getting the rise of a run. It's the same formula. Yeah, so that's exactly what you are doing, is you are trying to just work out the rise and the run. You're just trying to find the relationship between the variables to predict the outcomes. I'm not sure I understand your question. Could you ask it again?
I don't know maybe whether someone understands. Okay. Where is the rise when we are multiplying the x and the y, and why are we now only
finding it? Okay, you are finding it. So you are calculating it. Okay, so I think let's do this. Let's do this like this. Ah, there we go. Okay, so we use ordinary least squares instead of just writing y equals mx plus b, because y equals mx plus b is the formula for the line. Okay, it's where to draw a line. Okay, but OLS is statistical method to find the best fitting line for real world data. So real world data is not ever perfectly linear. The points don't fall directly on the straight line. So we don't have this. Okay. So the equation of a line, we're assuming that those points are exactly on the line, but it doesn't work that way. Even though we use the formula and we aggregate for the formula, they don't always fall directly on this line. They look like this. They are further away from the line. And that's why in the calculation, we're going to see we work with the y values, because the y values is the actual values. Okay, so remember, when we do machine learning and when we do statistics for machine learning, we're trying to predict y, but we're working in a class of machine learning now, which is supervised learning. When you're training these algorithms, whether we're working them out mathematically now or not, we actually know the y value. So if I come back to this, if this was a model, which it very much is, we actually know the answer for y. Okay, but we don't have a perfect line. So we have to find the best possible place to draw the line. And for the best possible place, remember what we have to draw this line. I wish I could show you guys my hand. I'm going to fiddle with this one. The best possible place we have to draw the line, we have two things we can do. Is we can move this. Don't do that. Let me see if I can get this to move the way I want it. We can move this line like this. Do you guys see this? That's one thing we have. Okay. Or we can move this line like this. Those are the two knobs we have that we can move with. Okay. So when a line is perfectly on the data like here, like a mathematics line, no problem. Okay. But the problem comes in, and why we are trying to find this y equals mx plus b is super easy, because we're cutting straight through. Okay. Here, we are not cutting straight through. It's not. We want to find the line to put it so that we can make this number the smallest possible amount. Okay, in this one, that would be 0 because we don't have any residuals. Okay, so in perfect maths, we know all of these coordinates and we draw a line. And yes, we use the equation of a line heavily in linear regression. The problem statistically comes in that we're not going to cut through all of that data. It's going to look like this and we're going to have residuals. So that slope is not a hard. This slope, I can always say, you can say it's a perfect slope and it's a perfect intercept, and there's no judgment of where this line is. In OLS, it's not perfect. The data is away, we have residuals, so we are working out sort of a slope and sort of a line. And to complicate things a little bit more, you'll see that we'll work out this whole thing. And then we also have to account for, we can't just work with one variable. So let's take it back a step and let's take the multivariable out of the equation, because I think that's where I've confused you guys. Let's do this again, looking at one single variable. We have weights here, okay, or heights here, and we want to predict weight. So we want to draw a line of best fit where these are the smallest. To draw the line, before we can even look what these guys are, we need a slope and an intercept. Because this is not a perfect line where we cut through, we actually have to go calculate the slope and intercept a little bit differently. So when we do this equation, we actually do look how far we are from the values, because we are subtracting x's from y's here. So we are doing that little thing here that I said, where you will actually subtract x from y, because we will have, oops, and we, we are bringing y values in here. And there's y and y hat, and we'll talk all about this, but we are actually looking, how far are we from the pictures that we draw? How do we draw this line? So we have to go find the best possible slope and the best possible intercept. And then in machine learning, in this example, statistics, in stats, while I'm breaking all my slides, we're just going to do it once. Okay, and we can then, but how it works in machine learning is a bit different, which you guys are learning the statistics for. We are going to go do this once. Okay, so we're going to work this out once. We are going to go find all of these numbers we need to find the slope we think is the best line. And then we're going to go find all of these values. Remember, working just with height to predict weight. We're going to move to multivariable slower so I don't kill you. So to find the best possible slope, in this example, we're doing it once. We're working it out, and we're actually going to use them here to work out our value. Okay. In real machine learning, we would do it once, and we would go do something like this. I'm going to find a free whiteboard. And that actually was a very good question before I forget to tell you that. Okay. So let me go find a, hold on just a second. Now you're going to be exposed to my horrible writing skills. Normally what should happen in machine learning, and what happens in statistics as well, but for simplicity now we're only looking at one example. So we're going to start, and actually we start at random, but guys, over time this will all percolate. Don't freak out. We have this data, okay? Okay, so this is, we want to predict the fish's weight, so this is our y, with the fish's height. Okay, this is the spreadsheet. Here is the data. I'm sorry, I keep clicking on the wrong spreadsheet. So here we got the height, that is our x, and we want to predict the weight. Okay, we got that. So now we want to find, because we're not cutting clean through that data, we have to go find our slope. Okay, so then we go like, okay, I'm going to OLS this, I'm going to do the equation of the line, and you go like, whoa, okay, so where is the slope? How do I find? I want to draw the line, but how the heck do I know where? So I know I need y equals mx plus b, but rise over run now is not that simple, because now I don't just have this gradual perfect thing that I can work out. So I have to find sort of a guesstimate, not guesstimated, calculated slope and a calculated intercept. So I calculate it for the first time, and it says, this is your slope and intercept, and we draw the line. How OLS works is we then go say, okay, how far was I wrong? And then you go like, oh, actually, you did a terrible job. Your first guess, which is how machine learning works. Your first guess sits over here. So that slope and intercept you got was pretty crap, eh? How about we go do it again? And we do it again, and we do it again, until we say, in this instance here, if we're going to work out our residuals, and we're going to minus them from our actual. So then we're going to see, oh, crap, this is quite bad. I mean, our error rate here is like 800, which is a bad example of a number. Okay. Then we go like, okay, so we missed the mark, definitely, because the distance from the actual data to the line is pretty far, actually, on all points. So let's go try again, and let's go draw a new line. So we go draw the new line sort of here, and we go like, okay, this is a bit better, but still those are pretty far, until we find the line of best fit. But to draw a line of best fit, we need to know where to start and how steep to go. And that is what we are calculating for perfect, imperfect data. Over here, we're finding where is my slope and where is my intercept to draw that line. Phew. Why do I keep, listen, I just want to explain myself. I have a brand new laptop, and we've moved from HP to Lenovo, and it is giving me quite a bit of highlighting issues. Did that answer your question, or did it indeed traumatize you so much more? How are you guys feeling? JC is okay. Ulrich, are you okay? Emil?
I think the principle I understand. It was more towards the formula that I was trying to understand.
You're thinking I've made it worse. Okay, all
No,
right.
no, I completely understand what you are saying and why we're doing it. My question was more if I look at the Excel sheet, but I think I'm busy making it make sense to me. So the height we're saying is the Y, and
Yeah, let's go work it
the
out.
X is the weight. So because we have multiple fishes, I think we have here, so that's why we had to come up with a formula and say the number of what do you call it, features, or is it observations?
This is
35.
observations.
Okay, so the number of observations times the sum of x and y, or x times y, which we calculated there. So this is just somehow a formula that gives us the
rise over run. Yeah, the
rise
guys to
over
work.
run. So
Yeah,
I think what I've tried to make sense of is how do we calculate the rise? How do we calculate the run? Or not how do we calculate it? Why do we calculate it like that? For
Like
that
that.
to make sense with the formula, yeah. I was trying to make sense of the formula. I understand principally what we are trying to do, but yeah, but I guess we don't do exams, right? So I can always come back to the to the formula.
No, actually, you have to apply the formula. Okay, so what you're asking me is a mathematical proof to prove that the formula is indeed correct and successful, and why do we do it that way? Okay, so
yeah,
so actually, if you're going to look at this, when we divide two things by each other, we actually get an average. So I don't want to say that because it's statistically too simple, but you can remember about it that we're finding it for all of these values, we're finding the average slope and the average intercept. Does that help you? And this is a perfect example where we're dividing by the number of observations. So you have 100 points and you got 80 out of 100, you're finding your average. You can think about it like that if it helps. But it isn't a proof for this formula in any way, but it's aggregating an average slope and an average intercept. Does that help you?
Yeah, I've made peace with that.
Okay. All right. So if you really want to know how this formula was derived, I can go look for you guys and do a maths deep dive, but that is more a proof than anything else. But happy to have a look for you. Okay. All right, are we expected to derive RLS estimators? So, Sanele, in this class, I'm always going to teach you guys exactly how stuff works and how we get there. But to do this kind of stuff in Excel, you have options. So, but it's very important in machine learning that you understand why things happen. So, what would really happen? And again, this is a new laptop, so I haven't even done that. So, this is a good example to show you. There is a option in Excel that you have to that you have to come in and enable. So there's actually built-in formulas that will do this. There's the analysis tool pack. Do you see this guy? So we're going to add them on. All right, and I hope I don't have to restart my Excel now, probably. But basically, you can just highlight this thing and make the analysis tool pack do it for you, and it will. And I have an example of that for you somewhere here, where I've used the analysis tool pack. Let me just find one for you between all my 9 million slides. Somewhere I would have used it. Otherwise, I have to restart everything. So it will work it out for you. It will absolutely work out that things for you, but you have to understand how it got to those numbers. I actually know where I can show you guys an example of this because I've deleted it from there. Hold on 5 seconds. Okay, and like I promised, we will go through all of these things over and over again until you guys understand. Please don't think you're all less lost and broken. This is an example of the analysis tool pack applied. Okay, so you can literally highlight that data, go into Excel and say, do this for me. And this is the output that you would get. And what it's going to give you is all of this information It's going to give you your error rate. It's going to give you your residuals. It's going to work out your intercept and your coefficient for you for one variable, or in this example, multiple variables. Because what I don't want to break you guys on is if we have multiple x's, we have multiple, and I'm going to actually just draw it for you now so I don't break you any further. We have one intercept, but we always have multiple slopes. So this is the Excel analysis tool pack that you will apply in your assignment. That's no problem. You will not lose a single mark for it. Okay. However, the problem is if that analysis tool pack is spitting out something that you don't understand, you will not know why. And it's important as someone that works in data science that you understand. And which is why your question about how that formula was proved is a very good question. It's like, why is it this way? Why do we do it this way? So it's important as a data scientist that you know how these values were found. How did we find this intercept and how did we find the slopes? How did we do it? So an example here where we're trying to predict the species with multiple different things, it will literally, and I actually saw, I had a picture from the previous class and the previous slide, but it will literally look something like this. For each variable, let me just refresh like I'm an old person. So for each variable, what will happen is, and if we look at this example over here, if we have multivariable, and we'll work it all out slowly, please breathe, we will find one intercept because there's just one place to cut. Okay. We will have one intercept where we cut, where each line cuts, but there will actually be a line cutting at the same intercept for height with its slope. There will be a line for width with its, that's not width, weight with its slope. There will be one for length 2, there will be one for length 3, and we add them all together to get to the answer, and we will work it all out. But you can see an example of how that happened here, that we have 1, 2, 3, 4, 5, 6 features, 1, 2, 3, 4, 5, 6 slopes. And in the way we've calculated it is we have added them all together. So we're going to say F16. Okay, don't know why I did it that way. That is an interesting question. But you were using all of these. Do you see them? All of them. And that same intercept. So we are saying that it is the value in A2 times its intercept plus the plus its slope plus the intercept. The value times its slopes. Oh, I've auto-filled here. So that's what we do with multivariable. Okay, so, and we will work out this example and the multivariable example, but that's just to get your M and your slope and your intercept to be able to do your calculation. And that was a very long-winded way to answer your question about you are allowed, you're not allowed to manually derive the OLS estimators, or you manually derive that slope and intercept, Sanele. You are absolutely allowed to use the Excel analysis toolkit. But in this class, I would do you a horrible failure if I don't teach you how the Excel analysis toolkit came to those values. And you will see that we are actually going to work it out on our own, and then we're going to double check it against the Excel analysis toolkit, and we always often end up at the exact same numbers. Okay. The yes or no, we can say the covariance of y divided by the covariance of x. That's also fine. Then is there other questions? So Mithat has his hand up, Bianca has his hand up, Kurtley, and Bianca, you're definitely not a him. Kurtley has his hand up. What would you guys like to ask?
Okay, I wanted to check if my reasoning is correct. When we add a feature, we are therefore adding an axis to the plane, right? So that means if we had x and y, now we have a z, correct?
Yes, 100%.
And then that means, so how I thought about it in terms of a vector, meaning that it has both magnitude, the line that represents the relationship, which is the line we're trying to get. It has both magnitude and it has direction. So therefore, if we're looking at an extra plane, it could be thought as each plane is tugging on the data point, and therefore we're trying to get the resultant of the force that each and every feature has on that data point. Am I correct?
You are correct. So let me explain this in plain English for anybody that was very beautiful math speak, but can I take this to plain English? Here's an example for you showing how we do it with vectors. So basically what he means is, where did I draw that picture now? So we're trying to predict this, y. Okay, and in this case, it's a species. Okay, so we're trying to predict how close we are to the value 1 for this species. So we're trying to predict that, but we have multiple things at play in that prediction and multiple things that can sway that prediction in various directions. So what he is saying is that each one of those features has the amount of impact it has and in which direction it impacts it. So in this case, how high this is like how you can calculate how heavy that amount of impact is. It's a simple example of putting it, but we're trying to say for this fish to get to this species, height has a say in what species it is. Length 1 has a say in what species it is. Length 2 has a say in what species it is. So does length 3. It also has a say in what species it is. And then how is it telling us what species it is and how do they fit into that hyperplane picture? So let's go look at a hyperplane with more than, let's look at a, okay, but I'm looking for one with many, many more features. But this is where we're getting to the space where we're looking at all of these features as tugging or having its impact on that variable and what is each individual's features impact. And what you will find is when we go deeper and deeper into machine learning, when we do feature selection, we are actually going to find that some features impact us so not that great that we're actually just going to leave them out. So how much impact does each feature have in predicting the thing? Because we might find that actually in this picture, we could have actually dropped these. There was a guy over here who like barely made it. He's just in there. We could have actually been like, you don't really matter. You don't have enough of an impact on predicting this species. Say there was a special guy like length 6 that didn't really have that much of an impact. That's what these kind of things mean. Absolutely. So now that we don't make people who haven't done maths and stats in a long time absolutely die, let's go work some of this out. And then let me actually quickly restart this Excel to see. Oh no, Serena, did you save your gyro data? Okay, 5 seconds. I'm just going to cry a little bit. Let's go restart this Excel guy, get that analysis tool packed in, and let's go have a look at what's going to happen. Please do not lose the gyroscope data. Okay, just 1 second, and let's go have a look at what is happening there. Let's see if we have that analysis tool pack now. Okay. Where is the analysis tool pack now? I did enable it, did I not? Was I losing my mind there? Yep. What did I do? Hold on 5 seconds. I was a bit off. I appreciate. We're gonna. Okay, well, I don't know if I should add the solver now and if I should add it later. There is the analysis tool pack. Okay, so I want to show you guys that are freaking out. So let's just say that we were going to use all of these, and what you would do is there's this. You're going to click on that data analysis and you're going to go look for linear regression. So it's actually not at all that you have to calculate this stuff 100% by yourself. It will also do it for you. Where the hell is linear regression? What have I broken? Just hold on. It will calculate it for you. Oh, did I add the wrong one? You don't have to do that manually, but it is important that you understand how that was calculated. Why the hell is this not showing me linear regression? Hold on 5 seconds.
I think it's regression.
You see regression and I missed it. Okay. Shout when you guys see it. There it is. You would just apply this, say okay. You would give an input range. I've already highlighted that. Okay. So this is available. Oh, that's the Y input range. Sorry, you will give it your Y. Okay, so let's say we are predicting weight. Did I break this? Let me just delete everything out. Okay, so we're going to give this the Y input range. Okay, then we're going to give it our X input range. And then we're going to tell it to just work it out for us in a new worksheet. We'll talk about what all of these things are. Let's just say we want a residual plot and we want to see the residuals. Then what it will do for you is this, is it will actually go and work it out for you. Do you see there's your intercept and your slopes? So this is what you would technically do in Excel. Okay, and this is totally allowed in your, and here's your residuals plot showing you for each variable what the residuals, those where we missed it with the line and how far they are from the line looks like. So you will 100% just do this with Excel. However, you need to understand how these things are calculated. This is a statistics course. So that's why you have to know how did we find this intercept and this X variable for each single one of those. And that is by using... Shoot, I almost made you look at a whole lot of stuff that would make you feel ill. It's by using this. So shall we do a calculation and check ourselves against that solver? Do you guys want to try that? Okay, let's go try that. Samsanga, are you okay?
Sorry. Hello.
No problem.
I had two questions.
Yeah.
The first question was on your linear regression Excel.
Yes.
Where I just noticed you're working only with the height and weight. So that example of calculating the slope on the Excel, you're only working with the 2 of the 6, correct?
Yes, we're going to start with the 2, and once we have that down, we're going to move into multiples.
Okay, that was the first one, and the second one was in the second, in the first formula, technically where it's the number of observations multiplied by x squared, then the sum x squared subtracted by the values. Yeah, but I'm looking at the spreadsheet, the Excel spreadsheet.
You're looking at this dude.
Yes. You see where it's highlighted in purple, and then you mentioned that there's a value that we have to square.
Yeah. Okay, let me
Could you just show which value that is? Because I see the value squared, the first one, but then you said to subtract it from the value we square, and I'm just a bit confused in that area.
Let's go do it together. Okay, so let's go and do this thing together so that we can see what is happening here and check everything. Okay, so we're going to be breaking a lot of stuff, but that's also good. So let's do this together. So what we are dealing with again is this. Okay, we have imperfect data. Okay, we do not have Y. We want to go draw a line, and we know to draw a line, we need to know the origin of the line, which is your intercept, and we need to know the gradient, the slope, the magnitude, whatever of this line, okay? But we can't just guess it. We have to work it out. So where do we draw this line? And we're just doing one iteration in what machine learning will do in multiple iterations, okay? So we need to figure out where to draw this line so that it is as close to all of the data points as possible so that this residuals, where we have missed the mark, where your y hat which is your predicted value, and when you minus it from your actual y, where they are not so bad. Okay, so where we have this as the smallest possible, the distance between we drew the line, between where we drew the line and the actual data points is as small as possible. And it's never right on the first iteration. You will see that that's why we do machine learning. That's why we do hundreds of iterations of this, to draw the line, see how bad our residuals. And we actually just do the sum of least squares. How bad is our SS? Oh, it's pretty bad. Let's try again until we get the smallest possible number, because eventually after we draw the line closer to these guys, it gets further to that guy. So we might swing too far that way and then bring it back. So we get to the point where we can find the smallest possible number. If we take all the actual data points from where they drew the lines, the distance, we square them, we plus them all to each other, what is the smallest possible number we can get? Okay, so that is why we need to know where to draw this line, and we can only draw a line if we know where to start it and how steep it goes up. Are we all together there? Are you all, can you show me a thumbs up or something that we're okay, that we have this data, we have to go draw a line and we need to figure out where to draw the line? Are we okay? All right. Actually, I just wanted to say thank you so much for asking questions. Last year's stats class asked me nothing and I felt alone. So we're going to apply this formula, and I will definitely go see the proof for the formula for you guys. So we are using height. So we're only using 2 variables. We will move to multiple variables, but let's take small incremental steps. So nobody in this class goes home tonight and wants to throw up. Okay, no vomiting in the dustbin. So we're following this formula, and I'm going to flip between the slides so you can see what the hell I'm doing. Okay, the actual formula, I'm going to, actually I put it in the spreadsheet, didn't I? Yeah, we're going to first go and say, okay, let's go find the slope. Okay, so to guess the slope, we're going to say, okay, so how do we do this now for this imperfect data? So it's going to say for each x, y point, so this is the x, y points, for each x and each y, calculate x squared. This mouse is going to be the end of me because now I have a root there. Calculate the x squared. So let's do things step by step. Okay. Let's go and square x. So we're going to say equals x squared in Excel. Okay. All right. We're going to enter it. And then because we have Excel, and this is why you use Excel, you don't have to go square each value. We can go all the way down and square that value. Okay. We're good with that. Are you guys okay with what we've done? Calculate x squared. We've taken x and we've squared it. Let me find you guys. We're all okay still? Okay. This is the point in the evening where you have to start checking what the hell I'm doing in Excel because I'll be getting old. Okay, the next thing we're going to do is calculate x, y. And why I did this in pink and highlighted it for you guys, x, y means x times y. And in formulas, they don't show that. They just put them next to each other. And if you're a maths person or someone that's been in maths for a long time, you'll just know it means x times y. If you haven't had maths since matric and you were like 43 years old like me, you'll be like, oh my God, what's that? So that's just so that you know. So then we have to go say, oh, well, this is incredibly difficult. What is x times width? Y. So we go calculate that. And then because we have Excel, we go, oh, thank you very, very much. Let's go and autofill this business. Okay, so we can say, check. Okay, sum all of the x values. Let's go do that. You can see that that is the original number that I had there. Okay, so check, done. Sum all the y values. Oh, actually, I just have to sum all of this. Sum all of the x values, sum all of the y values, sum all of the x times y values. Okay, so we can really just be lazy and do this. Okay, but there are our numbers. There we've got them. That gives us, now we have the sum of x, because most definitely we have summed x. And this is the sum of x, okay? And that is the math signal for sum of the values in the x column. The sum of y and the sum of x squared, okay? Right, we got those. So now we need to do the next thing. So we need to go and calculate the slope, because all we did is we went and built the parts for the formula that we need to use. Okay, So we've got all of these parts and we need to use them. So what does this formula say in English? It says, well, to do this, we need the number of observations. So to get these number of observations, we just said, okay, how many observations do we have? And we use the count thing in Excel and we just counted any one of the columns. And this is the amount of observations that we had, which is 35. So this in English says the slope equals this top line, the number of observations times the sum of x, y, the number of observations times the sum of x, y, okay, minus the sum of x times the sum of y. Here it is written out for us beautifully. Okay, so let's go look at that. We said we need the number of observations, 35, times the sum of x, y. There's the sum of x, y that we just calculated. That 341,800. Okay, times them by each other. From that, you subtract, and these brackets are here for BotMath, but also for Excel. From that, you subtract the sum of x minus the sum of y. Well, we did do that because here is the sum of x and here is the sum of y, and we are most definitely subtracting them. Okay, and that gives us the value on the top of the line, and we can then go and look at what is the value we need to divide by, the value at the bottom of the line. To get the value of the bottom of the line, that's where the squared things comes in. That's breaking the person that asked the question, which is a good question to ask because probably 9% of the class is thinking like, what the hell, where's that coming from? Because we talk about the sum of x squared, we squared it. Okay, we took x, we squared it, and we got the sum of that. So now what the heck is happening? This bottom part of the formula actually says, let's take the number of observations, 35, times the sum of x squared, minus the sum of x, just the sum of x, and in the formula we are typing, we square that. So let's go and do that. Okay, so let's go do that formula. And here I just gave you guys the tops and bottoms to show you how I got to that amount. But let's go work that formula out. Oh, I just divided those two because I was lazy. But it's saying, I'm saying to you, here is the Excel in formulas. The formula in Excel. So what did we do? Okay, so let's go look at how we work this out. And let's actually just go work that out together. Okay, let's go do that. So we put things in brackets because we need them in brackets. So in that first bracket, it says the number of observations. Oh man, don't break my brackets now. That's like really rude. Okay, the number of observations times with, take the number of observations times the sum of x, y, the number of observations times the sum of x, y. And we can see that these amounts are starting to tally up. Okay. From that, you subtract, but we're going to fiddle with the brackets now. From that, you subtract, again, brackets for Excel. From that, you are going to subtract the sum of x minus the sum of y. And actually, we want to put that in double brackets because we have to get the outcome of this. Oh, and we want to divide that by. So what this means is calculate this as a whole and this as a whole and subtract them from each other and hold the whole answer. Because we're going to divide that by, this is a lot of talking, the number of observations times by the sum of x squared. Okay, got that. Right. No, man. No, okay, sorry. And Excel is going to go all funny. Okay, minus. So we've got the number of observations times the sum of x squared. Okay, minus the sum of x. Now we square it. Are you guys okay? And that will give us that slope. Completely wrong. But that is why I put this here for you guys, so we can do that formula correctly. So let's just go and see what I've done with the Excel formula. But that's basically what you have to do. Oh, what the hell have you done here, Serena? Sorry. I will eventually fix this formula. But that's what we have to do to get to that sum of squares, okay? And that's what I did here, is I just divided the two. I'm just going to take a look at what I've done wrong to my formula, because it's a lot of brackets that you need to use correctly. So let's just go do them again. Okay, so if we work through the formula again, now there should be nothing here. Why do you have this output now? So let's go work through this formula again. I wonder why I have R in here. I wonder if I copied it. What have I done? There isn't even, oh, there is. Okay, so let's go do this formula again so that we can get the right value. But you're just going to apply that formula. And the only issue we're having here is brackets in Excel. And that is why I put it for you guys over here so that you can see where to put the brackets. Okay. But that's all you do to calculate this value. So we're going to go do it right again. And I'm just going to move this where I can see it, because I keep moving it out when I'm typing in there. All right. So, because we have to get to 102, because that is correct, because we will check it against Excel again. So
I think you
how
just
do we
need
work?
one bracket at the end. Isn't
Thank
it?
you. Do
And
you have
there's
money
an
on it?
And there's an extra, yeah, I think, no.
Now, what did we do to this formula? Does it need that and that? What have I broken? Let's just work it out one more time. Let me just go fix my stupid formula. Okay. So we need the opening brackets for everything. And then we need, oh, do you know what it is? Okay. We actually don't need the additional. Let me see. Now I've deleted it. What I think we need to do is this. Yeah, okay, I'm sorry, calm down.
I think
Yeah.
it's the square by S11. So if you undo and take the brackets.
Which bracket is missing? That one.
So put the bracket last. So the formula like you added just before this, if you undo what you just did now.
Yeah.
And then the bracket just before the square, take away and put the bracket after the two.
Ah, thank you. Sorry that took so long. Okay, but Excel is still having a gripe.
Still.
But that's
but now
okay.
you're
Let's
missing the bracket in the front.
Yes.
Yeah.
Yeah. Oh, this is going to drive us nuts. Okay, so now we're missing that bracket. Flipping hell. And which is still giving us completely the wrong number. It needs to be 102. Okay, let's just check these values. No, they are 100% correct. Let me do it one more time. Okay, like a knob. But this is just Excel. Yeah. Yes.
Serena, hi. I think it's got to do with you've got a minus sign as opposed to a multiplication. So if you go Control Z back to your formula that you had.
Where did I put the minus signs? Okay, let me see if we're going to get back to it. I don't think so. I think we're starting again here.
So can you see between S11 and S12, you've got a minus, it should be a multiplication.
Thank you. That took long. Okay, but there is our formula, and that is that formula correctly applied. So let's go look at this again. What do we have? Okay, we have, what is an S16? In S16, if we go look for row 16 and we go all the way to column S, that is the number of observations, which correlates with that N. Okay. What we are doing then is we are timesing it, but with what is an S14? So if we go to row 14 and we scroll all the way over to S, we will see that we are using the exact same value, which is the sum of X, Y. So let me just, because that's going to stuff up a fact like there, which is the sum of X, Y, minus the sum of X, okay, times, which is what I stuffed up, thank you, the sum of Y, divided by the number of observations back in this cell over here, which is S16, times by the sum of X squared, And then we go say minus the sum of x, which we then square, which is not the sum of x squared, which I didn't want to like confuse you guys with. That is how we calculate that intercept. All right. And let's just take this formula and stick it here for you guys so you have it. Thank you. Let me just delete this guy. And then let's just go grab this formula and stick it here so you have it. And then Excel makes me mad when it does this. Okay. All right, so there is the formula, so you can see it. All right, but that's just Excel formulas. There's nothing wrong with the math. There's clearly something wrong with my brain at 8:30 at night. If we want to see if we did a good job about this, we're going to test it against the Excel data analysis toolpack in a minute. So now we have our aggregated slope. So now we have to find that intercept. Okay, to do the intercept is also super, super simple. Here is the formula. To get the intercept, we just take the sum of y minus the slope we calculated why it needed to be correct, times with the sum of ex over the number of observations. Okay, and here I totally just took those two and divided them from each other. But that is how you then get to the intercept. You just take this whole business here, where you work it out. The sum of EY, okay, and then you just go, which is 21,624, and we get it from there, minus our calculated slope, that 102, okay, 704, with all its decimal babies. Okay, and we times that with the sum of x, which is 531,4124, and we can see it here as the sum of x, and it gives us this slope. Okay, if we go and see, does Excel agree with us? Let's go and apply this. Okay, so let's go and find regression. Okay, and let's change the values. So it's asking us for our y values first, and we said our y values is weight. Perfect. Then it's going to go and ask us for our x values. So let's go feed it our x values, and our x values is the height. Okay. All right, and then we say we wanted a new page, blah, 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 all the stuff. And will you look at that? This is exactly what we just calculated. If I can find what the hell I did with that sheet. Do you see that this is the values we just got from the Excel calculations? So 102.7, okay, so and it just rounded that one up or stopped at least decimals. But do you see that's exactly what we just calculated? Minus 941.5. Oh my goodness, it's exactly the same. 102.704, it is exactly the same, which is why you can apply the data analysis toolpack in your assignment. No one's going to stop you. But as someone that needs to understand these things and work with this kind of algorithms, you need to know where the heck these values come from. And you can be pretty confident in your calculations after we fix our stuffing formula is that they are correct because we can verify them against Excel. Okay. How are you guys doing? Do you want to throw up? Did this help you see how it was calculated? Yes, Samsanga. And then there's a question from Alize, and then there's a question from Bianca, and then there's many questions. Okay. All right. So let me go back. Yes, yeah, listening. Samsanga?
Hi, Serena. I wanted to ask, so I understand like the formulas, and everything to do with that. I understand where all the figures are coming from and how you get to all the figures. But the Excel part of it, that's where I'm lost. And I'm sure for our assignment, we're gonna have to be able to do all these calculations with the Excel like working pack. So that's where I'm a bit lost, like how you utilize like Excel to like get to all of these figures.
Okay. So Samsanga, the first time you're going to do this, and it doesn't help if your lecture breaks the formulas on screen, but the first time you're going to do this, you're going to be a little bit Okay, I'm not so sure how to do it, but we're going to do many examples and iterations of this. So the best case scenario you will have is in the assignment, they will give you a data set. Okay, so let's do this, and then I'm going to come to Bianca. In the assignment, they will give you a data set. So let's grab this guy. Okay. And let's go to here. So they're going to give you this data set, and they're going to tell you, okay, use linear regression. They're not going to use the word OLS, and we're getting there, guys. This is the first time you're starting with linear regression. Just breathe. They're going to tell you, take linear regression and work out the coefficients or work out the slope and intercept. So technically, you are totally allowed to go and say, I'm class. I now know how a slope and intercept is calculated. I now know how the equation of a line is used, all of that. Okay, and we're going to do the next step just now, but I know this. Okay, so because I know how it's calculated, I can use the built-in tools. I'm not using built-in tools that I don't understand. Then you're going to come like, yeah, sure, no problem. I'm going to work this out for you. Okay, so I'm going to go and I'm going to say, okay, I would like to use the regression toolbook, and I would like to put in my Y range, and the assignment says we are working out a fish's weight, and this is my Y values then. And we are also then using the fish's height to calculate its weight. So that would be that would be my X values. Where the hell's height? I almost took the wrong one. Okay, that will be my X values. Okay, so I'm going to take these. I'm even going to be lazy, and I'm just going to say, just shove it for me here in my own notebook. I don't want you to put it in a whole different notebook because I want to use them to calculate. So I'm going to do this. And I'm going to say, go for it. Work out my stuff. And now it's actually going to cheat and put this here. That's a little bit of a mess. I'll tell you guys how it knows how to do that. That's just some Excel magic, and this is also not fantastic. But hold on. It's going to go work out our slope and intercept for us. All right, so now we actually want to go and do this for each fish. But now all we're going to do is we're going to say, okay, I remember now. I want to calculate. So we're going to say, I want to go calculate the weight. Okay, so actually we're going to go say, well, I know how to do that because Y equals the weight equals the slope, if I can find it, M times X. Where am I? Y, I'm trying to calculate the weight, equals that slope times X. And we're only using one variable. Don't freak out. The rest is coming. Plus that intercept. What do you look at that? It would look like we are correct. And then because we have Excel, then they're going to say to you, I don't know what the hell happened there. We'll go look. But they're going to go say to you, okay, could you work this out for another fish? Okay, so what if let's look at a record we've never seen before. So what if we have a fish that is 12.38 centimeters long? Okay, can you please calculate that fish's weight for me? So you're going to go, of course I can. This fish's weight is Y equals, the weight equals M times X plus, I just broke this, did I not? This weight equals Y, the weight equals M.
I think you're gonna.
And I just broke that too. I'm just gonna put 102 there. Will you guys trust me? Okay, sorry. The weight equals Y equals M X plus B. There's the weight for the unseen fish. How are you guys feeling? So we now have a line, and we can use that line to make predictions. Are you starting to feel a bit better? Yes, you have tats. Nadia will go through it with you guys and everything will fall into place. Just breathe. And Nasipa, you are not drowning if you haven't been in math for a little bit. And there's something I want to tell you guys. As a lecturer, there's a stance I take. So I could have taken this spreadsheet and prepped it. Okay, so I could have come and delivered the perfect lecture. Okay, I would not have stuffed up that formula. I would not have done, so you wouldn't have seen me fiddle and struggle. Okay. But all I would have done is take you out at the knees, because you would have been like, it's supposed to be just a smooth ride. It is not. Okay. The stuffing up the formula, struggling with your stuff, that is the ride. So I never take the stance of delivering you a perfect lecture, because I'm going to paint a fallacy that is not the truth. And a lot of people in this class who haven't had math in a long time is going to feel really silly when they don't get their formula to work. But you guys, you don't get your formula to work flipping daily. That's a reality. Breaking code in the other thing, that's a reality. Okay. It's all super duper learning. Be gentle with yourselves. Don't freak yourselves out. Just breathe. You will absolutely get there. Okay. I'm going to go to that multi-example. And from now on, you can use the regression tool. Don't go manually calculate it. Use the regression tool. No one's going to manually calculate that stuff. But it's important that you know how it's calculated, how Excel gets to these values, what the hell they are, and why we use them. And it's important when things go wrong and you have to trace your step back. So I want to go back to this slide, and then I swear I'm going to let you guys go to bed. And thank you that you have survived thus far. So I'm going to go to this slide, where because we actually showed you how to do multivariable a long time ago. Okay. So to do more than one feature, so the prediction is y. Okay, there's our slope. So we start with the slope for 0 times the x for 0 plus the intercept. The slope for 1 times the x for 1 up until p. So what does this look like? If we go look at this fishy logistics, what the hell did I do with fishy logistics? If we go look at and you guys, there is a YouTube video where everything from last year is also recorded, and you guys can see me break more formulas. But if we go and we look at more variables and we use multiple variables, so here you guys can see I've used the Excel toolkit to find the one intercept for me and the multiple slopes. And that's what we did here with weight, length 1, length 2, length 3. Okay, so let's go here. Let me just refresh this thing. Right. And then we'll come draw as we go. So here all I've done is I've used, and please don't look at the log. If you look at the log on the probability, I'm going to kill you. Don't look at that. Okay, so let's just take this data. Okay. And first break everything. That is the rule. If we don't break it, so we're even there. So let's go do this a bit differently. So we're going to keep with, I'm just going to insert a column here, and we're going to say this remains. No, man, what the hell? That's not, wait. Sorry, this is going to be our y. We want to predict weight, but we want to consider length 1, length 2, length 3, height, and width. Okay. So A, we're now not going to go manually calculate this. Although as a class, you now know how to do this, and I'm really proud of you for going through that. But now we're going to say, no. I'm just going to do this. I'm going to take the data analysis tool. I'm going to say regression. I'm going to say that this is in fact my y values. And in this data set, I actually have different fish. This is effect. But now, all of these are my x values. Okay, and there's some outliers and stuff in here we'll play with later. But these are all my x values. Here, can I please give you an output range? Can you put them over here for me? All right, Excel, do your thing. And what we're going to end up with is this. That's all we will discuss, and during the course you will learn what all of these things mean. Just breathe. There's your residuals. We will know what all of this means. We'll talk about all of these things. It's all in the slides. but we will get there. Do you see that we get a single intercept, and for each single one of the variables, we end up with a slope? Do you guys see this? It works out a slope for every single one of these. And it does it in order as they are appearing. So it will do the slope, the slope, the slope, the slope, the slope for each one of them. Okay. And you can see that in the size of the numbers because those are really relatively small. Do you see that? And then there's relatively bigger numbers. So it works out the slope for us like that. So then if we had to go do OLS in this case, and I'm going to show you in here and we'll do it together in the next class, but I think I'm flipping murdering you guys. Also, you've gone flipping far. Okay. But if we're going to go look at how this OLS was calculated. Okay, let's look at the first guy. All right. We need to find, we have F16, okay, plus A2. What the hell, where is A2? What have I done with this thing? What is it? Oh, because, never mind, don't look at what I'm saying. But we're going to go work it out because this is actually a logistic regression sheet. That's why it's called fishy logistics, but there is an OLS component to it. But basically what we are going to do, and none of my formulas match what I've copied and pasted anymore, but all we are going to do is we're going to say, we are going to work out mx plus b for each single one, every single one of these, and add them all together in the end to give us our OLS value. So you're going to see that you have times width plus, times width plus, times width plus. So we will work it out for every individual one. So that's how you do it. But let's do that in the next class and not tonight, because that will then be y equals the weight of the slope of 0 times the x of 0. This is our 0th record. So it will be, or our first feature, and it will be to take the x value times it with its corresponding slope, plus the x value for the next feature times its corresponding slope. So that will be then the next column, and its corresponding slope, plus the next column times its corresponding slope, plus the next column times its corresponding slope, at the end, plus the intercept. That's all you're going to do, is you're going to take y equals m times x plus 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 b. Is that making sense to you guys? Are you okay? Oh, Bianca, your hand has been up for a long time. Sorry, are you okay, Bianca?
Yeah, I'm fine. Just 2 questions.
Yeah.
One question is, how do we know that in the first example that the x value is the height and not, for example, length 1 or length 2?
You decide what the x values are. Okay, so you absolutely decide that. So I'm going to show you a different data set to tell you how we know this. Okay, so let's go on to Kaggle, for example, and go look at a data set there. I'm going to use Iris because it's kind. Is that okay with you guys? Even though, what is wrong with this computer? Okay, so as the data scientist, you are going to know what the was, because this is supervised machine learning. The answer is known except for new observations. So you are going to know. So you are a fish specialist. You know that we calculated we choose height or weight. You decide that. The data set also tells you. So hold on. The data set will also tell you that. And it's maybe if I also show it to you in Python, it might be a bit easier to see. But the data set shows you that information. Why is it not bringing up the bloody Iris? It's definitely time for us to have like, oh, and it's the UCI one. Okay, so if you go look at a data set for machine learning online, and that's also why I got a fishy data set, by the way, it will actually tell you which is the Y value. So they have different names, but you will know. So in a lot of cases, it's typed out like that, like species name. So you decide what you want to predict. So in this case, it's classification, and we know the Y values is Iris or setosa or anything like that. If you wanted to calculate petal width, and that's also something known as domain knowledge. So you know the answers and what you have to work with. So in this case, we would know to find a iris, we look at petal length, petal width, sepal length, and sepal width. Those are my X variables. Those are my known guys. And they act on Y. They change Y. So if as the sepal width and sepal width and sepal length changes, and the petal width and petal length changes, that has an impact on the species. That's why it's called the dependent and the independent variable. So the species of flower is dependent on what the sepal length and sepal width is. So you will know yourself, it's always known to you what is Y and what is X. Did that help?
Yeah, thank you. And then my second question, can you please go to the second example?
The long one.
Yeah, please. Just one question.
Yeah.
So in column O, where we have that, it's 6 X variables, how do we know, for example, the first X variable relates to length 1?
So in a lot of ways, if you use the data analysis toolpack over time, you'll just know. The other thing you'll do is you'll look it up. So if you don't know, you will go and you'll just have a Google and go like, which variable relates to which thing in Excel. So you'll look up the rules, same for SPSS, same for R, same for Python. You'll just look up the rules of which variable represents which one. Okay. So, but there's like, and then it will just tell you the data analysis toolkit does it like this, because there's also other additional data analysis tools you guys get to build into Excel, but I don't know if they're all for free. They work slightly different. So as a rule is, if you don't know, just look it up. And that's the reason you guys are not writing exams, because there's so much of this that you actually have to be able to look up. Like at this stage in your career or in your exams are a stupid way to test somebody, because if doctors also don't remember everything off by heart, you're going to forget. You should be able to look stuff up. So, oh my word, if you guys have had lectures for 3 hours, are you okay? I just looked at the time. Yeah, so you look it up, Bianca.
Okay, thanks.
Okay, Mvelu, if you need layman's terms, please WhatsApp me about the ones that you're understanding, not understanding. Okay. Yeah. All right. And remember, guys, that things don't just sink in the very first time. You have to give it time. This is your second stats lecture. If you're not running around and you haven't done this before and it's your first time, if you're not running around going, what the hell just happened to me? I don't know. I don't feel well. This is scary. That's completely normal. So, and I think the ones that were in the PDAN class was there when I asked Joseph, who's a previous stats student who wrote exactly this, exactly messages like this, going like, I feel like we're going through the how to calculate everything but the what and the why is still a bit unclear for me. We need extra help with the underlying concepts, formulas, all of this, please help. That's exactly how Joseph felt. And Joseph graduated this class with a 98% average. That's nothing wrong with you. It's a lot of information. There's nothing wrong with you. You are not slow. This is not too difficult. It's the second class. And the only way to understand stats is to practice, 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 practice. So you should leave this class going like, oh my word, that was a lot. But as long as you're saying, I'm starting to understand the calculations, I'm starting to see the pattern of why we do things, I'm just not clear of the why and the how, you're actually quite far away. And I want to add something to the list of channels that you are looking for. Someone that you want to look up is also a channel called Stats Quest. That's Josh Stromer, and he works for Chapel Hill. So when I did university stats, I'm not going to talk, just last year, I swear, we hang on to, that was our savior when we did this course. That was someone that was really significant in helping to understand stats. And the other thing is you need to watch many, many stats videos, because my explanation might not be the explanation that lands for you. It might land for some people in the class, but Joss's explanation might land spot on for you. So I'm not the oracle of knowledge, you guys. There's beautiful YouTube channels to go have a look at. Okay, as long as you are able to calculate. No, the textbook is nuts. Okay, as long as you, no, you do need the textbook, and I will take you guys into the textbooks and show you, but the textbook is not in the most accessible English. Okay, those Tabile, we're not going to scream. No one's going to scream. We're all going to be fine. Stats is lovely. No one's going to die. Everything will be okay. And I always do this. I'm going to ask you this 4 weeks in, how you feel now, and you will feel completely different. Manyapaye, oh, I did it again. You had your hand up for a long time as well, and I didn't get to you.
Hi. Yeah, I just wanted to ask, this is just regards to the add-in you'd used in Excel. Would we also be
Yeah.
able to just add that data analysis feature in? Yeah, that's just what I wanted to ask.
Yes.
Because I tried to do it while following, but I couldn't quite find the add-in. Yeah, so just wanted to confirm that.
So if you go to File and Options, and if it's not there, then we have to talk about a VM. But if you go to File and Options and Add-ins, and then don't be doof like me and not click on the thing, you're going to click on Add Analysis Full Pack. You're going to say Manage Excel Add-ins and say Go. And you should see these options. And what you really want for this course is the analysis tool packed and the solver add-in, because we're going to use the solver add-in for gradient descent. If you cannot add it, yeah.
Sorry to cut you off. Should it look the same using iOS or Mac Excel? Because yeah, I'm not quite getting to the tool pack. The add-ins
Okay,
tool
let me
pack.
look for you. It might not be the same, and you might actually have to download something else, but let me have a look for you. And there is other ones as well that you can use. And there's also online ones, hey?
Okay,
So if you, yeah, so there is analysis. I'm just quickly looking this up for you.
So on Mac, you just go at the top there, there's a tools. So you go on tools, and then it should be there.
I can see the add-ins, and then it asks me to find more add-ins in Microsoft App Source. And then when I search it, I don't find the exact one we're using here. So yeah, just wanted to ask.
The data analysis.
Yeah, unless, yeah.
Okay, that's something I will happily look up for you and post on the group, because I actually don't use Mac at all. So I'll look it up for you and I'll post it for you on the group. And then the other thing is, I don't know if they've spoken to you guys, but you will have a virtual machine installed with Windows in the cloud that you can use. But also just do a Google for online tools. There's many nice online tools that you can also use. If there's anything due for next week, no. But what you do need to do for next week is take this spreadsheet. And that's why there's multiple sheets. Take the spreadsheet, delete and practice, delete and practice, delete and practice, to the point that you no longer are like, what in the actual hell is going here on here. Now for the postgraduate speech. At postgraduate level, you should have prepared. Okay, you couldn't prepare because I couldn't be prepared because I couldn't get onto ARC. But you can't show up in a class completely cold and think you're going to be okay. You have to read and you have to practice. So Nadia will have a tutorial with you guys where she's going to go through it super slow, super easy. She would have prepped it so there will be no errors in the spreadsheet, but I'm never going to teach a lecture where I don't make errors, because I'm going to make you afraid of errors, and that's so, so dangerous. Errors is the light to the answer. They're nothing else. Practice, practice, practice. Okay, so you guys, Mary, yes, the textbook is valuable, but I need to show you guys in the next class if you remind me how to read the textbooks. Okay, your group numbers mean when you've registered, the time of the year you've registered, it basically just means ARC, the LMS system that we use, they only put 50 students into a grouping in ARC. You will all have the same lectures. You will all have the same assessments. It's just how you grouped on the ARC platform, and grouped in the institution. So if you had face-to-face classes, you would have had classes at different times. Group 1 would have been, because I would have had to take all 3 groups for this. Group 1 would have been 8:30 to 10:30. Group 2 would have been 10:30 to 12:30. Group 3 would have been 12:30 to 2:30, and then I would have died. That's what the groups mean. Number for you. Okay. And then I just want to tell you guys, please ask questions. Don't be afraid. Okay. And I don't want you to come to this class thinking you have to be a math whiz. Just come to the class and listen. And we're going to break a lot of stuff together, but I promise you will be just fine. In the next class, we'll recap everything we've done in this class. Then we'll really work through the multi-feature scenario. And then we'll look at how do we see how far are we wrong. Okay. And then how do we apply those? When is the TUT? Nadia will advertise that for you on the WhatsApp group. And I'm so sorry that I made you guys have 2.5 hours worth of lectures. What time was your lecture supposed to stop? Yes, Arich, there's apps. Yeah?
The lectures are supposed to start 6:30 to 8:30. And the tutorials, my tutorials is going to be on Fridays, 6:30 to 7:30.
So you've only been here 20 minutes extra. No, I don't feel sorry for you at all. Okay. All right. So what is due for next week? Take that spreadsheet and practice. I didn't type out that formulas for my health for you in plain English. I didn't draw all of those tables for my health. I didn't structure those spreadsheets for my health. And what we're going to do in the next class is we're quickly going to run through that spreadsheet again. I'm going to use a clean version. We're going to run through and do our calculations so we can practice and refresh. And then we're going to do the multi-feature explanation so we can practice and refresh. And then we're going to start looking at how do we evaluate. Because remember what I said, machine learning, this is one iteration and there will be multiples. How do we see how far we are wrong? And then how do we use that to make decisions? Okay. Muketsi?
Hi, I think somebody asked before how to add an analysis toolkit on Mac. Obviously you just go to tools and then you see at the bottom it says Excel add-ins, and then that's how you can add the analysis tool pack, just in case you don't know how to.
Okay. Do you guys know what I would really appreciate? Is there any one of you as a Mac user, because I sadly am confined to the horrible world of Windows, if there's any one of you that is a Mac user who want to make a 5-minute video, you don't even have to talk, just don't play like some people play very weird music in the background, that will make a 5-minute video of how to add the data analysis toolkit for Mac and just stick it on the WhatsApp group. We would be so appreciative. I would also look it up. Nadia, there is a question there for me to say, could you repeat the timings for the tutorials?
Okay, yes. The time for the tutorial, my tutorial is on Friday, 6:30. If you go to the WhatsApp group, description, the class time, and the tutorial time and links are there.
Okay. Yeah. All right. And then Nadia, there's some WhatsApp questions that I'll forward to you. Do you guys have any other questions while you're here? While we're here, I have 7 more minutes to give you. Do you have any other questions?
One last question, please.
Sure.
Yeah, I just wanted to ask about the activities that we have in the learning units. I saw they're like for 5 marks and they open up a discussion. Are those like you just do? I'm not too sure if we went over this. Like, do we just do them? Are they timed? Or like, do we have deadlines? Yeah, I think, yeah, just wanted to ask.
So those activities and the marks in them are arbitrary, and if the activity is useful, you do it. Okay, if the activity is not useful to you, you leave it. They're just stuff there for you to practice. Okay, so in this course, the things that will gather marks is ICE. I use ICE tasks to help you for your assignment. So I'm not going to give an ICE task in the first lecture, but I'll probably give it after the next lecture we have. I'll issue an ICE task, and that ICE task is to prepare you for something coming up in the assignment. So that it will gather marks, and that will have a deadline. Okay, and then obviously you have assignment. No, it's assignment 1, assignment 2, and assignment 2. Hey, I haven't spoken my socks.
Yes, it's 3 assignments, 2 assignments, and then 1 POE.
Then 1 POE or 1 summative assessment. So and then every lecturer is able to assign 4 ice tasks per module. I very often don't assign 4. For me, ice needs to be meaningful. So I would rather give you an ice task and you do your first assignment and I see something that's people are struggling with, and I will then give an alternate ice task. Or I usually use ice tasks for after Nadia. How many things did we mark last year? Nadia and I marked ourselves last year that we were crawling on the ground. After marking all of those, we'll have a very good idea where people are struggling and where everybody in the class is struggling a bit, and then we will formulate our ice tasks around that to prepare you and help you for the upcoming assessment. So that's how I handle ice. But I will only, oh my gosh, I'm no longer the lead lecturer, Daryl is, but that ice is just for preparing for the assessment. Nadia, do you mind sharing the link for last year's lectures for the people that are freaking out? So you can have the link. We recorded every single lecture last year, and I also recorded short form videos for you guys next year, and I'm going to ask Nadia to put that link in the chat for you. You're very welcome to go and watch those. Okay, and you're welcome to watch the linear regression one over and over again. Obviously, we'll upload this video, but you're very, very welcome to watch last year's lecture videos, and it might also help you prepare for further lectures because I don't want you to feel stressed, okay? All right.
A link to the WhatsApp
Thank you.
group.
Okay, so what you're going to do now, all of you, is you're going to go make yourself a warm cup of tea or get a glass of wine or hug your emotional support animal and remind yourself that you are 2 stats lectures in, you are not going to